My name is Faisal Razzak and I am Senior Product Manager at Venafi. I'm joined by Jim, Co-Founder and CEO of Nirmata. We are here to talk about a very interesting challenge faced by security and engineering teams working on cloud native technology. That challenge is to build and run secure containerized workloads in Kubernetes. Digital transformation is enabling enterprises, big and small, to provide value to their customers in a fast and consistent manner. The backbone of this transformation lies in the adoption of modern DevOps practices and containerized workloads. This presents a unique challenge for security and engineering teams of building and running secure containerized workloads in their production environments. Keeping this challenge in view, several bodies responsible for providing IT guidance to governments, industry, and larger open source community have outlined container image signing and verification as baseline security practices for modern IT environments. NIST, through its special publications 800-218 and 800-190, have identified the need to sign containerized workloads. CNCF, through several of its white papers, have also identified the need to sign and verify containerized workloads. Center of Internet Security, in their recent guidance around software supply chain security, also identified the need to protect integrity of all software components. OWASP's Software Assurance Maturity Model also gives guidance to development teams to incorporate integrity verification of all software components. In summary, container image signing and verification are baseline security requirements for building and running secure containerized workloads.
Thank you, Faisal. So signatures and signing are not a new topic for any of us. Long before computers even existed, all of us have been used to, signatures for paper documents, of course. But the same notion of being able to prove the origin of a document, which we're used to in the physical world, also translates to the digital world. Digital signatures, of course, go a lot further and can also prove that the contents of what is being signed have not been tampered with. So, how does this translate to the modern world of containerized applications and workloads? Well, containers and a container image are really just a set of files which are stored on disk and transferred from one system to another at runtime. So given this notion and given the fact that these files follow a standard format which is defined by the Open Container Initiative specification, or OCI, part of the Linux Foundation, what as the container image is built, what can be done is a unique hash can be produced to identify that specific container image itself. So now that we have the set of files and we have a unique hash or digest, signatures can be used to sign those contents and then verify those contents on when that container is ready to be used. In addition to signing the contents of the container image itself, we can also sign additional documents about the build environment, which serve as proof points of how the container image was built, what type of environment was used to build it, including the machine identities, the other build systems, the or data that is captured at build time. So once we have the container images signed, and before we run these container images, we want to verify these images itself. So in the security world, there's a term called zero trust architecture. And what that means is you want to verify every interaction in a modern system. So if you think about it, in a modern enterprise today, there might be millions of interactions across systems, across machines and tools. And to verify each one of these, policies are required at any significant scale. A digital policy is really a codified contract which is stored as in digital format and can also be transferred from one system to another within the enterprise. In the context of containerized applications, the different roles that are involved in these digital policies are the developers producing the application, the security teams responsible for securing the application, and the operations teams that are providing the runtime environments like Kubernetes, a popular container orchestration system for these applications. So the policies that you would want to use to check the properties of these containerized images need to be applied at every phase of the deployment lifecycle of the application. Specifically, these policies need to be applied before that container image is admitted into a runtime cluster, into an environment like your dev test, staging, or production environments. These policies can check various attributes, and what you would want to check is where that container image was built using the digital signatures, and also that the container image has the right properties that we require to allow it to meet with the compliance and regulatory standards that Faisal talked about. So now that we understand what digital signatures as well as digital policies can do, Faisal will explain to us why signing and verification matters to a modern enterprise.
Thank you, Jim. The IT network around us is changing fast. We are seeing and will continue to see exponential growth of machines in this decade. This is a result of digitalization of our daily lives. More machines mean more applications being developed to meet our needs. According to Gartner, 75% of organizations will have deployed containerized applications in production by 2023. Attackers have also realized this trend of containerization. They are also pivoting and targeting software supply chains, causing negative impact on business operations. Gartner believes that by 2025, 45% of organizations worldwide will have experienced attack on their software supply chains, a threefold increase from 2021. 50% of the existing attacks are attributed to APTs or well-known attackers. According to Gartner, by 2025, 60% of organizations will have hardened their software delivery pipelines to protect against such attacks. Now let's see what are the best practices for adopting the security practices of signing and verifying container images. Based on our engagement with several customers, it all comes down to finding balance of requirements between enterprise security team, your platform team, and developers. Enterprise security team is focused on ensuring compliance with industry standards and ensuring security policies are being enforced across the enterprise. Platform team, on the other hand, is focused on making sure that systems are available for both internal and external consumers. An application could be an example could be a team managing OpenShift, Amazon EKS, or Azure AKS. Developers are focused on building applications that can deliver value for the enterprise quickly. Let's see how we can create this balance. Our experience shows enterprise security teams want to manage signing keys and eliminate private key sprawl from their environments. Adopt a code signing process across the enterprise for different teams. Have visibility into container images being signed. Provide audit and ability to enforce security policies. And importantly, automate key management and signing process. On the other hand, platform teams want to build and run secure containerized applications in clusters. Never deploy unsigned container images in cluster. Integrate with existing deployment environments. Have visibility into container images being deployed. and importantly, automate the verification process. Developers want to integrate with existing container image signing tools like Cosign, Podman, Scopio. Integrate with existing application development processes and tooling. Now let's go back to Jim for the demo and see how these practices can be adopted at the implementation level.
So in this demo, what we're going to see is two different phases, the signing and then the verification, and four system components that work together to make all of this happen. First of all, in the build system, we would be running a client which is able to securely access enterprise signing keys through a central machine identity and certificate management system, and to sign that container image which is being built and which will be deployed into a production or a test system. So in a modern enterprise, you might have hundreds of builds operating in parallel. So it's extremely important here that the signing keys are secured and they're always encrypted. They're not left in the build system itself or not in your repositories, but can be securely obtained at runtime in real time, right at the moment of signing itself. So this is what the client helps with. And then the enterprise policies that the platform and security teams control are in the central management platform for your machine identities, your builders, as well as for the certificate management policies that need to be established. Once the container image is built, it is pushed into your OCI registry, which acts as a central store from where container images can be pulled at runtime. And before that container image is deployed into your runtime system, for containerized applications, typically this is a Kubernetes cluster, that container image needs to be inspected for its security attributes, including the expected digital signatures. This process is done by a policy engine, and the policy enforcement point is called admission controls for Kubernetes. So right before that image is deployed, the policy can be used to check for the right signatures and security posture. Now, of course, again, in an enterprise, you might have hundreds or even thousands of clusters spread across different teams, different organizations, and roles. So to manage all these policies at scale, a central policy administration platform or policy administration point is essential. These policies can be deployed. Different policies might be in place for different environments based on the teams who need access into those environments and how the signing rules are laid out. So those are the four components: the client running in the build system, the centralized machine and certificate management system on the build side, the other two components being the policy enforcement and policy administration, that all need to work together to accomplish the signing and verification portions. So let's take a look at this in action for an actual image, which we will deploy to a cluster itself. So here I have a single repository which has this sample Venafi CSP image. As you can see, there's a V1 version of this image being built. And what we're going to try and do is deploy it to my cluster. For the demo, I'm going to use my local Minikube cluster, which is a local Kubernetes environment that I'm running. So the first thing I'm going to do is I'm just going to run this container. And right now on my cluster, I don't have any policies installed. So if I run this container, what I'm going to expect, and we will run this container, which points to the same image that I have built with the V1 version. And I'm going to use this parameter to dry run it with the Kubernetes admission server. What this means is that it's not going to actually deploy the image, but it's going to test how the deployment would work and give me back the results. So at this point, I expect that Kubernetes will allow this pod to be created because there's no policies in place. And what's interesting at the moment to note is there's no container image signatures in place itself. So what we want to do is to be able to apply some policies. And I have a policy configured, which if I now look in my cluster, if I do get cluster policies, I see there's a policy which is checking for image signatures, and it is set to enforce mode, which means it will block admission for containers which do not have the appropriate image signatures. So if I try to now run that same command again, which previously succeeded and was able to create a pod, what I would expect is that the policy checks for the signature and fails, which is what we see here. And there's a descriptive message for developers, which tells them that it's missing the matching signature. So what can we do about this, and how do we fix, our signature or apply a signature into our container image? So typically for this, what would happen is we would run a workflow on our build tools. In this case, I'm going to run in my Git repo itself. I'm going to run an action, which is going to build this container image, a new version of it, and which is going to sign it. So this takes about a minute or so to run. But the first step here is to be able to, go through, and this could be any language. It could be Python, could be Java, JavaScript, any language which gets built into a container image. Now, interestingly, what we also have is once the image is built, in my pipeline, there's a couple of additional security steps we are implementing. We're going to generate a software bill of materials, or SBOM. And we're also going to scan this image for vulnerabilities, which is a good best practice for security, to do periodic scanning. And all of this data, along with the signature for this image, can be signed and pushed and attached into the OCI registry. So now that we have completed, as you see, the pipeline just finished generating the SBOM, kicking off the scan image. And the final step that's going to be executed is attaching the digital signatures to both the image as well as any metadata that we want to check via policies. Now, one other thing to point out is that the way this pipeline is designed is each time the build runs, a new machine is created for the build, and the build environment itself is secured so that it cannot be tampered with, or any malicious actors cannot interact with the build environment, to make sure that the signing and verification and the right provenance data can be attached as this build is done. So now that this pipeline is completed, if I go back into my image and click Manage All Versions, what I can see is, along with my container v1 version itself, there's also a signature and other metadata which has been attached to the image. So let's go back to my cluster and try the same commands again, which previously, as you recall, the policy had failed and or had checked for the image, and because it did not have a signature, it was not allowed to run. And as you see now, because my v1 image has a signature and the policy is able to verify that, the pod is able to run. Just to kind of, again, show that if I run another container, so let's say I just run some sample container which doesn't have a signature from a public registry, my policy will immediately block that and deny access to my cluster for that particular container. So what we saw in this quick demo is the ability to be able to sign securely in a CI/CD pipeline, and then also to be able to verify at admission controls before your cluster is being deployed.
Thank you, Jim, for the demo. We are all witnessing increased attacks on key organizations by APT groups and malicious actors. Adopting the security practices of signing container images in your development pipeline and subsequently verifying the integrity of container images in your deployment environments are steps towards secure containerized workloads. Therefore, folks, sign and verify.